So, hello again, and today we're going to do some more exercises on matrices, linear systems, and such things. So I have 3 exercises, and as in the last video, I'm going to first solve them, and figure out solutions, and by writing, let's say, a draft, and then we'll take care of the writing of detailed solutions. So let's start with this first one, which is just a linear system. So you know that a way of solving this linear system, which also depends on a parameter, so we have to be careful, is by using the Gauss-Jordan elimination. So consider the following matrix obtained from the linear system, which is as follows. Okay. Fine. So we know that there are moves which are allowed, and for example, what I can do first is to exchange these rows. So get okay. Okay, fine. Okay, this is nicer because you know that you want to put this matrix in a nice form, in the so-called row echelon form. So here we would need a 1. So let's get a 1 here just by dividing by, we just divide by 2. So if you want, if I multiply by 1 over 2 here, so this becomes 1. This becomes 1 over 2, and this becomes 5 over 2. That's okay. Now let me see. This is the second. This is the third row. And okay. Now I'd like to have a 0 here. And so what can I do is, what I would like to do is the following thing, namely, let's replace the third row here by itself plus t times the first. Okay, and now you can ask, you would ask me, but well, didn't we say that this is allowed only if t is different from 0? Well, of course, if t is different from 0, then it's okay. But what if t is equal to 0? I'm just replacing the third row with the third row plus 0 times the first, which is again the third row. So I'm doing nothing. So it's not a problem. I mean, you can take any t here. We don't really have to assume that t is different from 0, because if it's different from 0, then it's an allowed move. But if it's 0, we're not doing actually anything. So it's still okay. So I can actually replace the third with the third plus t the first, and I'm getting this. This is again so this is 0, this is same. And here it's 1 plus t over 2. This is 1 plus 5. Okay, that's good. Now you see that you have t minus 1 and t minus 1 here. They are the same, so you can just, again, replace this is again the second, the third. You replace the third row by the third minus the second. This is perfectly okay. Again, we are not assuming anything on the parameter so far. Fine. 0, 1. So this is again the 0, 0, and here you have 1 plus t over 2 minus t, and if you do the computation, this is 2 plus t minus 2t, so it's 2 minus t here. Fine. Fine. And here it's 1 plus 5 over 2 times t minus 1, so that's okay. That's okay, very good. And so now we are in a nice situation. Where this matrix is triangular. So we would like just to have ones here. So now we actually have to make some assumptions. Namely, we want to divide by 2 minus t here, for example. So first assume that t is different from 2. I stress again, as in the previous video, it's very important to make these assumptions here. So you can go on by and doing divisions. If you don't assume this, then you're dividing by 0. It's not allowed, and it's just wrong. So let's just assume this, and just make a 1 appear when we want it. So multiply, for example, by this number, the third row. So this is 0, 0, 1, and this becomes 5t. So that's okay. We're not there yet. So here you see that you have a t minus 1 here. You would like this to be a 1. So we assume we are assuming here that t is different from 2. We are assuming furthermore than t. Furthermore, assume t is different from 1. So we can go on and divide the second row. Very good. 0, 1, t. Okay, that's good. So in this case, we can just solve the system. So we first find that from the last one, we have that the third variable is going to be this 5t divided by, and this is it. And from the second one, we get, substituting, then we get y plus 5t. This is equal to this. So this is just computations, so no worries here. Okay, this is 2 minus t minus, and this is it. This should be correct. Yeah. If you want to slightly nicer way of writing is just do this. So just like multiplied by -1 above and below. So no worries. Okay, then this is it. Oh, let's put another page. Very good. Very good. So let's go on. And this is y. And then you have the first equation, which is x plus, what is it? 1 over this, and this has to be this. So this is x plus, sorry, x plus, yes. Okay, this, so x is equal to this minus, so it's just this. Let's do okay, which is then 10 minus 10t. I mean, these are computations. They're not really essential, but so it should be 5 minus 5t divided by. So in the end, you should have x. In this case, just one solution, namely x is this. Y is given by, if you want, and the last one. Okay, very good. So here we are assuming that t is different from 1 and t is different from 2. So it's not over yet. We have to look at what happens if you have t is equal to 1 or t is equal to 2. So let's just look at this thing. Let me just copy it. Just right before we divide it by t minus 2, or 2 minus t, which is like, actually, so let me copy this, and fine. So this is just before we divide it by anything. So what if now assume from here, assume that t is equal to 2, then you get what? You get 1, 0, this, then 0, 1, 2, 1, and here this is 0, 0, 0, and that should be 5. So from this row here, you see that you can't have solutions. Okay, and then let's assume t is equal to 1. So just substitute. And okay, this is, yes, this 0, 1, 1. And this is now, yes, let me see, 0, 0, 1 over 2, 5 over 2. And here you get 0, 0, 1, 1, 0, 0, 1, 5. Then, yes, if you want to, you can replace the third row here by difference and you would get then 1 0 0 0 1 1, and this is going to be 0 0 0 and 4, and again from this you see that there are no solutions. So we are done. We're finished. We know that in this case, so if the parameter is different from both 1 and 2, we could divide things, and we found this only solution, which depends on t. And on the other hand, if t is equal to 1, you have no solutions, and if also t is equal to 2, then you have no solutions. But you had to discuss these values like apart. Okay, we're going to write a detailed solution later on. So let's just move to the second exercise. And this one is an exercise on like manipulating data with matrices, and it's very similar to the one we've done last time in the last video. So you have this data. You just have to organize this data and make some multiplications in order to understand things. So I'm just going to read the exercise just for the sake of like clarity. So a manufacturer of garden supplies produces building packages for sheds, garden sheds, and greenhouses, STMP. The needed amount of wooden planks, glass, and labor is as follows. So it's here. And then you have the costs. It's given in euros. And you have 3 distribution centers, which orders a number of these packages, and we want to understand the cost per distribution center. So how do we do this? We just like build some matrices. So as I said, the way matrix multiplication is defined tells that you can interpret a matrix as something, as a table when here you put some input and here you get some output. Okay, so for example, this data, I have in input some raw materials, wood, glass, and labor. I mean, labor is not really a raw material, but it's something you have to use. So WGL, and you get some output, which are the goods, the supplies. So sheds, garden sheds, and greenhouses. Okay, whatever this is. So it's going to be 12 here. Now it's just a table. And 8 here, nothing here. Glass is going to be 2 here, 15 here, and yes, nothing here, I think. And labor is going to be 2, 8, and 5. So this is the first matrix. And then you have this is the production matrix if you want. And then you have the costs. So in input you have euros here, and in output you have the raw materials and the labor. So it's going to be WGL 10, 20, 17. Okay, very good. And then you have the distribution matrix. So the 3 distribution centers order some packages. So the output is going to be like the 3 distribution centers. They receive the packages, and the thing you put here is going to be STP. So they want these things. These things. So this is 100. Now we just like copying things. Fine. Very good. Now you see that this like input agrees with this output, so we will be able to multiply, and we can actually right away do things, do the computation. So we want something which is costs per distribution matrix, per distribution center. So we have euros here in D1, D2, D3 here. But in order to get this, which is what we want, we're going to like multiply. So here, this you have this matrix. So I'm just copying, okay, very good. And here you have STP again. This is the production matrix. You see that this agrees with this. This is important. And here you have WGL 02828. And very good. And then you have the costs. Here, WGL and the euro 10, 20, 17. And by doing this matrix multiplication here, you can actually end up with a new matrix which is like has euros here and the distribution center here. And that's what you want. I'm not doing the computation, but yeah, this is it. Then if you just do the matrix multiplication here, then you're going to find the costs you need. And this and that's all. This is just the way you solve this. So it's not very difficult. The last one. So recall that a square matrix C is symmetric if it's equal to its transpose. Given the following matrices, which ones are symmetric and which are not, and we have to say why. So the definition here of symmetric matrix is that yes, it's equal to its transpose. So what we have to do is just compute the transpose matrices of these given matrices, and we just check whether they are equal to the original ones or not. So the first one is the zero matrix, the null matrix. So how do you compute the transpose? Well, the definition says that the rows become the columns and vice versa. So the first column is given by the first row of A1. So well, here it's actually nothing interesting to say, but yes. So the first column is the first row, but it's just 0, 0, 0. The second column is the second row. So yeah, just to be clear. So here I'll put things which are here, but it's again 0, 0, 0. And finally here I'll put things which are here, but it's again 0, 0, 0. And indeed you will find out that this is equal to A1. And let's do this for the A2 TR. Again, here, first column, you have the first row here. So it's going to be 1, 0, 0. And the second column here is going to be this one. So it's just 0, 1, 0. And again, the third column here is going to be the third row here. So it's 0, 0, 1. And again, you see that it's equal to the original one. So, okay, so this is symmetric. The first two matrices are symmetric. Fine. Whereas the last one. So again, this is the first column, and here you put the first row. So 1, 2, 0, 1, 2, 0, and the second column here is going to be the second row here, so minus true 1 0, and finally the last column here is going to be the last row here, so this is 0 0 1. Very good. And then you see by direct inspection that this is not A3, because yeah, here you have minus true, whereas here you have true, and also here you have true, whereas here you have minus true. So it's not symmetric. And this is it. This is everything. This is actually everything. So it was actually very short, this last exercise. And now, as promised, our last effort is going to write the detailed solutions for each exercise. The most boring one is going to be this linear system, unfortunately. But yeah, let's do this. Sorry. Okay, let's start. So here, just put a new page here. Okay, so solution of Okay, so let's be very clear and detailed, and and let's write in a way which is nice to read. This is always the goal. We have to write solutions which are nice to read. Okay. So let's see. We solve the given, if you want. Using okay. Consider so which was the matrix was this one. Okay, let me just copy this. Well, this is something you can't do when you don't have a tablet, but at least here that's good. That's perhaps just oh, sorry. Okay. Well, handwriting is, yeah, so far not too bad. So 1 2 3. Okay. This is it. So first thing we've done was we switch first row and the third row. So we get this 2 0 1. Is this, yes, okay, should be okay. Okay, then we multiply again. This is so 1 0 1 2 5 Very good. So okay. Again, this is replace third by what? This was third plus t times the first, and just a reminder. I mean, you don't really have to write this in parentheses, but just a reminder. This is allowed because if t is equal to 0, we are replacing by itself. I mean, you don't have to write this, but yeah, if as a suggestion, if you want, if you feel that some argument, some like some step of your solution is trickier than the others, or it's, let's say, if you just feel that it's a tricky step, so you want to give some more details so that you feel safer, then just go on. It's okay. It's okay. It's perfectly okay. And it's actually it can actually be useful, because perhaps some other people will find that step kind of tricky, and by reading your solution they can still have a detailed explanation. So when in doubt, just be very detailed, and I mean, don't be afraid of being a little bit pedantic. On the other hand, if you want to write less, then you are taking risks. It can be done, but you have to be it has to be clear. You have to be careful, because you are taking risks. So if you have to be really you have to think about what you're doing, and be careful not to not to how can I say, not to avoid writing something which is essential. So again, if you're in doubt, then just be detailed. If you're being pedantic, then it's okay. It's not a problem. It's not a problem. Okay, so let's just go on. This was just a suggestion. So let's just replace the third row by the third plus t times the first. So we get finally this. So this is the same. This. So this is 0 finally. This stays here, and here you have this. Very good. Again. Okay. Oh, this doesn't look like the third, but okay. Now we just subtract the second. Okay, very good. So this is 1, 0. 0, 1. And okay, this is 0, 0. This is 1 plus t over 2 minus t, so you can like just write this if you want. True, it's going to be true plus over 2 is going to be true plus t minus 2t, so it's going to be this. Oh, sorry, just need to smaller. Okay. Okay. Should be good. Let's check. Let's just check this. Yes, 2 minus t over 2. Okay. So here you say I took a little. I took a very small risk by just like skipping computation. I mean, computations, if they are like straightforward, you can somehow skip them in the detailed solution. But then just like be careful, because some readers can think, well, and then what have you done here? I'm no more seeing what you're doing here. So like, yeah, as I said, when skipping steps, then you're taking risks. So if you don't want to take risks, and if you're like if you're not really experienced, then I suggest you don't take risks. But as in this case, if you want to take, you can take these small risks. But then, yeah, in that case it should be like it's here it's very clear what you're doing, so who reads should be able to understand that this minus this is indeed this, and they can also check it by themselves if they want. So it's not really a great risk I'm taking here. But if you don't feel like it, if you want to write every step even of this computation, then just do it. Don't worry. It's better not to take risks if you don't feel like so. Okay. So now then again, 3 minus third minus the second, so 1 plus this minus 1 is giving this. Okay, and this is, as you remember, this is the moment when you need to start making assumptions on the parameter. So well, no, sorry, I need another thing here. So we assume t is different from 2, and divide, well, let's say multiply third by what you have a 1. You want to have a 1 appearing here. So by 2, okay, this should be, and then you get this. Fine. So this is 1 0 1 1. Very good. 0 t minus 1 t 1, and here you have 0 0 1 and 5t. Very good. Let's just check that it's the same thing we found before. It seems so. So 0 0 1 and this 5t over 2 minus t, which sounds good. So okay, very good. And now furthermore, we assume t different from 1, and multiply the second row by this. So you get okay. Very good. Let's check that it's again that this corresponds with what we've done before. It seems so. Here it's more, of course, it's more drafty here. 0, 1 t over t minus 1. Yes, it looks okay. Very good. Now we can let's write this a little better. So the point is, what I want to express now is that we can now find the solutions of this equivalent system. So this is the right thing to write. Okay. Solve. So, as just a reminder, the point of the Gauss elimination is that you change the linear system with these allowed moves, but at each move you do doesn't change the set of solutions. So equivalent linear system here means that it has the same set of solutions as the original one. So so it's like this, x plus y plus and this is, so you know that in this case what you have to do is just substituting variables. Let's say if you want to write it here, you can say by substitution. So you know this, and then you just substitute in the second one. So this is going to be x plus yeah, it's quite boring, but I'm just substituting everything and just check that it looks okay. 5t 2 minus t looks fine. Looks fine. So this is y plus 5t squared t minus 1 2 minus t is equal to this. Well, it has to be a little longer here. And this is okay. So now you just compute. Let me just reorganize the space a little bit. Let's move it here and here. Well, just to save some space, don't worry. Unfortunately, you won't be able to do this on paper, but if you want. Okay, then you can find x is equal to 5. Here I'm writing all details, So what is this? 10 minus 5t minus 5t, which is again 10 minus 10t divided by, so it's going to be 5 minus 5t. Okay. And it looks like it's the same as we've had before. 5 minus 5t over 2 minus t. That's okay. That's okay. Very good. As for the other, y is then this minus very good. Let's just okay, minus t, yes, minus, okay, which is again, if you want, multiply by minus 1 above and below, and then you get t minus 1, t minus 2. Okay, that's good. And the last one. And the last one is, yeah, you already know this. So we're done. So if you want, just circle this. Why? This. Okay. So let's just check they correspond with things we've already done. So it seems so. 5 minus 5t over 2 minus t. Yes. And then you have this ugly thing. 5t seems fine. Seems fine. Yes. And the last one, 5t, it looks okay. So this is the conclusion of this first part. If t is different from 1 and t is different from 2, I'm going to stress this and is very important in the sense that we are assuming both this and this. Okay. The system, the given linear system, has only one solution, or if you want, has a unique solution. Since we now don't want really to write again this xyz given by the above x, or if you want, you can say that this is okay. You can also say given by, you can also express the solution as this column vector where x, y, z are given by, and you put a reference here, and that's okay. That's okay. It's not over, as you know. So we have to look at the other cases. Again, if I have to plus here. So in order to be clear, let's write this. Let us now take the for namely this one. So let me copy. So what I'm doing here, since this solution is like quite long, I'm just like I'm just rewriting some things in order that who reads does not have to go back and get lost into the previous paragraphs of the solution. You can also do something like this. So you put something here. Let's say just a little triangle here. And you can, instead of recopying things, you just write this. Without having to recopy this thing. But well, in this case, I mean, namely, you can do like something like this. But well, in this case, since I'm on a tablet and I have to go back pages, and it's not the nicest thing on video, then I'll just like put it here. But yes, it's something you can always do, making references, putting some markers like this, or we've done also this before here, and make references so the reader, while they read, they can just go back to the equation you're referencing, and this makes this avoids that they get lost while reading your solution. So I want to stress out again, the point in writing a solution is you have to think that someone is going to read this, and this someone is a human being, and they want, and they're going to like, and to want a solution which is clear, which is nice to read, and which and avoids avoids moments when they get lost in the paragraphs. So if I didn't put this reference or this thing, then as a then the reader would the reader had to go back and look at the specific step, but chances are that they couldn't find it, and so they would become like pissed off because they couldn't follow your solution anymore. So it's very important that for readability, if you want to reference something which is few paragraphs away, then do something like this, or repeat yourself. It's okay. It's perfectly okay. So, but let's now go back to the solution in this case. So now we have to, as you know, we have to study the cases when t is equal to 2 or t is equal to 1. So I'm just going to write if t is equal to 2, we get what? This 0, 1, 2, 1, 0, 0, 0, 5. And here you can conclude immediately from which you conclude that given the linear system has no solutions. Okay, and if t is equal to 1, we get what? Yes, just substitute. Okay, 1, 0, 0, 0, 1, 1, 0. No, it's okay. 0, 0, 1 over 2, 5 over 2. That's okay. Here, here we replace the third by the third minus this multiple of the second one. Did I do something wrong before? It can be. So here, when solving this, no, not really, not really. That's I think it's the same thing. Well, I mean, let's just be comfortable. Let's do multiply. Sorry. So you get this 1, 1, 0, 0, 1, 5. We replace a third. So again, let's be clear. By third minus the second. Is this the second? Bad handwriting, sorry. Okay. And here 1, 0, 0, 0, 4. Okay, we conclude well, let's be even clearer here that a little bit redundant, but I mean, as I said, being redundant is not bad. Let's repeat. If t is equal to true, we conclude that if t is equal to 1, I'm just repeating things. I mean, it's not really necessary, but I just feel I just feel safer by repeating some things sometimes. The linear system has no solutions. And this is it. This is it. This is a nicely detailed solution of the first of the first exercise. So yeah, it was like quite boring to write because it was a little bit longer than perhaps the system we've done last week, in the last video. But yeah, still it's okay. And this is a neat solution. Okay, let's go on to the other exercises, which hopefully are going to be a little easier to write. Okay, so let's add this. Okay, so solution of how can I write this? Let's do this. Let's write this. We organize the given data. Organize using the following matrices. So let me write P is the production matrix. And this is, and it's given by this. So what was it? STP and WGL 12 0 true 8 true 8 0 15 5. Good. Then we have the coast matrix C. Coast matrix. Oh well, perhaps just here. Okay, is equal to. So this is euros. Very bad euro. Euro W3L. Fine. What was it? 10 20 17. And finally D. The distribution here you have D1, D2, D3, and here you have STP, and this is 12 170 and 50 40 0 80 0 0 200. Okay, so we conclude the costs per distribution center are given by the product handwriting. The product what? So that was D P C, which is like, just to be clear, it's going to be have euro here and D1, D2, D3 here. A, B, C. And of course you don't have to to do the actual computations here. It's not important. I mean, this is a perfectly neat solution. Let's just check. This is actually D, this is D, this is P, and this is C. It corresponds. That's fine. That's fine. That's perfectly fine. Yes. Yes, fine. This is it. This is a good solution. Okay. Finally, let's move to the final exercise. Here it's like quite easy to write this solution because it's kind of quick exercise. So let's do this. Okay. So we compute. Let's write this A1TR. It was again what did I do? Sorry, this is my fault. Okay. Okay, and this is equal to A1, hence A1 is symmetric. Then the second, that was again the identity matrix. Was it? Yes. Hence A true is symmetric. And the last one. So that was like, yes, 1 minus true, 0, true. Oh, sorry, 1, 0, 1. And it looks fine. This is different from A3, hence A3 is not symmetric. Okay, and yeah, this is it. If you find an exercise which is like quick, or you find it easier than the others, and you feel like you can write a nice solution right away, yeah, you can like try and do this, but it's another risk you take. You're not like doing the first attempt and drafty way, but you try to write down a nice solution right away. If you feel like it, then you can try to do it. But if you don't feel like it, well, just first reason on it, write your draft, and then take your time and rewrite a detailed solution, so that, as I said, I'm going to stress this again, whenever you write a detailed solution, you have to check what you've done thoroughly, and this enables you to, this allows you to find out if you've done some mistakes, because when trying to write something in a nice way, then it's easier to spot mistakes. They're more clear. You can feel them when during the write up of the detailed solution. Then if something doesn't look good, then it's very easy. It's very easier to spot it than just in the draft, where perhaps you made some wrong reasoning at some point. So I stress again and again, this is a very important thing to do. And but at least as for these exercises, we are done. So this is the third one, this is the second one, and the first one was longer, so it took even 3 pages here. Yep, this is it. So okay, it's everything for today, and I'll come back with another video with some other exercises in a few days. Now, normally should upload one video each week. So yes, thank you for watching and see you next time. So let's stop.